Hello students, welcome you all for physics session. Dear students, last class we discussed about electric potential energy for various cases such as single charge, two charge system, three charge system and n number of system of charges. At the same time, we have discussed about what is the electric potential energy of an electric dipole when it is placed in external electric field. Now move on to, in these all concepts, we are moving on to electrostatics of conductor. First of all, we already know few things or few facts about conductor. In today's session, we are going to be discussing about more information and more things about conductor which are related with electrostatics. Okay now? Now in this session, we are going to be discussing about the few points which are related with electrostatics of conductor. And initially, I want to conclude you people is that these all are somehow proved up to some 99.99% extent, and few are of convection. Okay, now move on. So those convection we have to study as it is. Move on. First of all, inside a conductor, the electric field EF stands for electric field. Inside a conductor, the electric field is 0. So, students, for every statement, we have to study as it is, or else if you want to prove the statement, we need to prove how exactly it is, or else the second way is, we have to prove this is incorrect. So, here I have chosen the second point, is that if I want to prove the statement, I want to decline it, or I want to deny it, first of all. Okay, but I will choose the second way is that I will explain the things, I will describe the things in a such a way that I need to show this is incorrect, this is wrong. If suppose I did not done it, the statement is right, that is the thing. Okay, now inside the conductor the electric field is 0, right? So how one can conclude it, how one can agree the inside the conductor electric field is 0, because we have defined the electric field as it is the amount of force to bring a charge or apply to a source charge. E is equal to F divided by Q we have written, or else we may have the formula E is equal to 1 divided by 4 by epsilon naught Q1 divided by R square. That is the formula we discussed in the last class. But here what we are saying, inside a conductor there is no electric field at all, nothing but electricity, electric charge is not at all. The statement meaning is no, right? But this is not in actually. Why? Because this is not a meaning of the inside a conductor electric field is 0. Because if suppose we have said that inside the electric conductor we have the electric field is non-zero, we have some amount of electricity inside, nothing but there will be no action of external electric field. There will not be no need of applying any external source to it, right? So we'll say that inside the conductor the electric field is 0. Second, at the surface of a charged conductor, the electric field must be normal to the surface at every point. Let us say this whole board has your surface. If suppose surface of a charged conductor electric field must be normal to the surface at every point. We have studied the electric field. How exactly the electric field lines enter the surface? Normal to the plane surface. No. If suppose these are in the direction of electric field, what happens? Angle, electric field and electric field lines and the electricity will be in the same direction, hence there will be 0. There will not be electricity, there will not be electric potential because angle is 0. Isn't it? Now move on to, so we have to agree that at the surface of a charged conductor, electric field must be normal. Electric field must pass through in this direction. This is what the plane surface, electric field has to enter in this direction in such a way that we have to agree with the second statement. Now, third statement. The interior of a conductor can have no charge in the static situation. What is this? It's just giving the meaning or explanation of the first thing. The interior of a conductor can have no charge in the static situation. Yes, this is true only, no? There will not be no need of explanation at all because it is static. And as we know, in a static motion, the charge will not move. So, though, we'll say that interior of a conductor have no charge. Fourth, the electrostatic potential is constant throughout the value of a conductor and has the same value as on its surface. Yes, it is true always. Why? Because if let us assume that we have some conducting material. Let us say at this point we have a potential V1. If suppose we have the electric potential as V2, if I have here V3, V4, so on up to Vn, if the things goes like this, we can't have a uniformity at all. We can't apply the uniform electric field to this surface. Nothing but charge will resemble in any direction as they want, and which is not true, no? And because of that point, electric potential is constant throughout the surface. Finally, the last point, the electrostatic field at the surface of a charged conductor will be, and this point was studied in first chapter, that is Gauss law. Okay, na? So with reference to that point, we need to agree with this statement is that E is equal to plus or minus a sigma divided by epsilon naught, where sigma indicating electric charge density, and as you know, charge, it may be a positive charge or negative charge. Because of that, I have written plus or minus divided by epsilon naught, and epsilon naught is absolute permittivity of that particular medium. Well students, these are points related with the electrostatics of conductor. In next session, we will go for extension part of this session. Okay, thank you.